Welcome to the next tutorial about the basics of the FSD. In the last tutorial we configured our hardware by adding some modules and elements. In today's tutorial we will create the corresponding logic. On the left we find the in and output elements we configured earlier. They are structured by module and we can find each element under the module where we have placed it in a hardware configuration. In this selection window you can also find basic and application specific function blocks. Let's start creating our logic. First we will take the input elements, the mini-twins and the e-stop. The color of these elements is yellow because they are safe elements. Now I want to connect them with an AND function block. Go to function blocks down here and click on the AND block and drag it in the main window. The function block is orange at the moment. There are also these nodes telling us that our configuration is invalid. This is because not all inputs of our function block are connected. To connect the e-stop, click on the blue square and as soon as we start dragging, all possible connections change their color to a lighter blue. We drop it on input 1. And again with one of the light curtains. Now the block changes its color to yellow because all inputs are connected. However, we still have 2 light curtains left, so we need 2 more inputs. Right click on the block and then choose Edit. A new window pops up and on in and out settings we can change the number of inputs from 2 to 4. Now we can connect the other mini-twins. Let's also add a reset block to our logic. We find it under the cluster Start Edge. I place it next to the AND block and wire it. If we accidentally wire to the wrong input, we don't necessarily need to delete the connection. We can easily reassign it by holding down the control key and then drag the node to the right input. On the other input, we now add our reset. But instead of wiring it, we can also drag it over the node of the function block and it is wired automatically. In this example, we configured the reset as a non-safe element. Therefore, it appears gray, while the e-stop and the light curtains as safe elements are yellow. This makes it quite easy to distinguish between safe and non-safe elements. Let's also implement the lamp to show us when a reset is required. Therefore, we go to Outputs and then to the module where we have placed the lamp in the hardware configuration. With all the basics which we learned, we can now finish our logic. Finally, we have the possibility to also label our page by adding a page node. Click on this button and now we could type in a description for our whole page. Additionally, we can also put single nodes on the logic page directly by clicking on this button and dragging it in the logic editor. In this example I call it machine logic. This feature will get more important as the logic gets more complex. If we now switch to FB preview, the important system resources such as the number of used and available function blocks or the current logic execution time are displayed. One quick tip before I end this tutorial: if you place the wrong function block and want to replace it, you don't have to delete it and connect all in and outputs again. Just drag the new block over the existing one. If you now drop it, you have the option to replace the current block. So we now finished the logic of our example application and learned how to use the functions of the logic editor. In the next video we will simulate our logic to see how it works.